Good morning, students. We shall move to the next topic, and it is a very important topic in coordination compounds. So, in most of the competitive paper, we have seen that IUPAC nomenclature. So, IUPAC nomenclature and coordination compounds, already we have studied about the ligands. So, there you have come across with different names. So likewise here also, the same thing we are going to use it here. So writing the formula as well as writing the name is different from the normal compounds. So IUPAC formulation and nomenclature of coordination compound. So formulation is nothing but formulas. So if at all if a name is given, then how to write the formula of that particular compound. That one. Nomenclature is nothing but names. So it is formula as well as names how to write. If compound is given, then how to write the names of that particular compound. So for that, certain rules are there. First, we are going to study about the rules for writing formulas. So for writing a formula, what are the rules has to be followed? For that that one first we are going to study. So rather than writing formulas, writing names, that is nomenclature, is very, very important. So until now, either in competitive or in case of theory paper at least, so nowhere writing formula is being asked. So nomenclature, writing names only is very, very important. But since it is there in our syllabus, we are going to study that one, as well as it also is going to help us in writing the names also. So first one, rules for writing formulas. Under that first rule, the formula of the cation, whether simple or complex, is written first, followed by that of anion. So this rule, it is normally in an ionic compound we used to do that one. So normal ionic compound is nothing but NaCl. Let us consider NaCl. So it is Na plus and Cl minus. So cation we used to write first, then it is followed by anion. So here you might get confused with this one. Whether simple or complex is written first. Simple in the sense, so in one of the complex, so this is the complex. In one of the complex here, K plus it is, and this complex part is negatively charged. That is, it is 4 minus. It is 4 plus and it is 4 minus. So in this part, this is the simple ion. The simple part is written first since it is an cation, and the complex part is followed by that one. Likewise, in few examples we have seen. That is, let us take an example of this one. En3, it is SO4. So in this example, if you check, so the complex is with minus 2 as the charge. It is with minus 2 as the charge. It is with plus 2 as the charge. This is with minus 2 as the charge. So complex cation, so it is being written first, and the simple ion, it is followed by that one. So either if the complex is a cationic complex, then anionic counter ion will be followed by that one. If the complex is a anionic complex, then cationic counter ion will be written first. So whichever might be the case, but cations we are going to write it first. Either it may be a counter ion or it may be a complex. So here cation is the complex, it has been written first. Here counter ion is the cation, so cation is being written first. So first we have to write the cation, and then it is being followed by the anionic part of the complex. Next one, the coordination entity is written in square brackets. So already we have studied this one. So coordination entity is nothing but a central metal atom which is bonded to the ligands. The central metal atom which is being bonded to the ligands, it has to be enclosed always in a square bracket. The counter ions will come out afterwards, or counter-ion will be outside the bracket. Either if it is a cationic, it will come first. If it is anionic, it will come after the square bracket. So the coordination entity is written in square bracket. The whatever the things which is there, which is written in inside the square bracket, it is nothing but the central metal and the ligands. So it indicates the coordination entity. Third rule, the sequence of symbols within the coordination entity is first the symbol of the central metal atom followed by ligands, and the ligand should be in the alphabetical order. So this is in coordination entity. So already we have seen in a coordination entity we have a metal, central metal followed by ligands. This is the general formula of coordination compound. A central metal atom or ion, it has been followed by the ligand, and the number of ligands we are going to mention. And this ligand, if at all, if only one ligand is there, no problem. If at all, if more than one ligands are there, then the alphabetical order has to be maintained. So that is the third point. So remember, ligands in alphabetical order. This already you know. This we have come across with many complexes. So you are more familiar with that one. But remember these things. So ligands in alphabetical order. Suppose if at all, if it is an polydentate ligand, the ligand is an polydentate ligand. So the ligands also has to be alphabetically listed. That is nothing but they have to be written in alphabetical order. So if at all in case of abbreviated ligand is nothing but short forms. So that is symbols we had written. So if at all, if it is ethylene diamine, we have mentioned that one as EN. Likewise, we have oxalate. So oxalate, we have mentioned that one OX. Or C2O4 2- has been mentioned as OX. So the abbreviated forms, alphabetical order we are going to use. So polydentate ligands are also listed alphabetically. In case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in the alphabetical order. So if at all, if it is ethylene diamine, then we are going to consider E as the first letter, and if at all, if some other ligands are there. So let us consider if some 2-3 ligands are there. Let us go with this one only. So we have cobalt, we have Cl2, and we have En twice. Like this, a complex is there. Let us think. In this, C is chloro, C comes. For ethylene, E comes. So alphabetically we have written that one. I hope it is clear. We have two different ligands here. One is chlorido and another one is ethylene diamine. So ethylene diamine, we have abbreviated that one as En. So where E is the first letter and here C is the first letter. So according to the alphabetical order, C comes first. So that's why it has been written first, and it has been followed by the next polydentate ligand. So this point is very, very important because the remaining everything you'll be remembering, but this one, in case of abbreviated ligand, the first letter of the abbreviation is used to determine the position of the ligand in alphabetical order. So this is about ligands. Fifth rule, polyatomic ligands are enclosed in parentheses, but all ligands are written without any separation in between. That is nothing but polyatomic. It is not polydentate. Remember, polyatomic, if it is an unidentate ligand or if it is an bidentate also, if at all, if it is an polyatomic, if it is there, then it will be written within the brackets. That is what parenthesis. So if at all, if it is an monoatomic, if it is there, if it is an monoatomic, if it is there, single atom, if it is there, then no need to write that one within the bracket. So, but if at all, if you are writing that one in bracket also, it should be with like continuous, it should be. There should be no gap. There should be no separation in between. That's what the fifth rule says. So, polyatomic ligands are written within the bracket, but all the ligands should be written in continuous. That is without any separation in between. We have come across with many such kind of ligands, and many such kind of complexes we have come across with. So we shall take up one of the example here. So cobalt with amine, tetramine, Cl, and it is NO2. It is NO2. So outside we have a counter ion as Cl. So in this, observe, so we have cobalt as a central metal atom. Cobalt as a central metal atom. It is followed by the ligands here. So we have first as ammonia. Ammonia is a polydentate ligand, and polyatomic ligand. So Cl is an monoatomic ligand, and here also once again it is polyatomic ligand. Even though it is unidentate, this is also unidentate, this is also unidentate. But these have two atoms, so polyatomic. This is also is having two different atoms are there. So it is polyatomic in nature. So names, if at all, if you are going with the names, already we have discussed the ligands are arranged in the alphabetical order. Amine, so NH3 is nothing but amine. Cl is chlorido, C comes here. NO2 is NO2 minus, it is nothing but nitro. So A, C and N. So it is arranged in the alphabetical order, and there should not be any space in between the ligands. So there should be continuous. So after central metal atom, so the ligand should be written in a continuous manner, and it should be enclosed in a square bracket. This is the coordination sphere or coordination entity. It should be enclosed in a square bracket. After that, counter ion. Since the complex is cationic complex, so the counter ion is anionic. So the complex part is written first, then it is followed by counter ion. The same thing here also, there shouldn't be also any gap between the ionic parts. So this is the positively charged part, and this is the negative part or cationic part and anionic part. There shouldn't be any separation between the cationic part and the anionic part. Next, next rule, there should be no space between the ligands and the metal within a coordination sphere. That's what we have already discussed. In the coordination sphere, so there shouldn't be any gap between the ligands. Next, seventh point. Seventh point is nothing but it is about the charge. So if at all, if counter ions are not there, then the charge on the complex has to be mentioned. The charge on the complex will be mentioned. So above this square bracket, write superscript. The charge will be mentioned as the right superscript. In that also, so suppose if at all, if 3 plus is the charge, then the numerical value will be written first. The numerical value we are going to write it first, then it is followed by the charge. The numerical value will be mentioning first, and then it is followed by the charge. It is not only plus, even if it is a negative or negatively charged complex also same thing. So we are going to write the numerical value, then it is followed by the sign or charge. That's how the charge on the complex has to be mentioned. Next, eighth point, the charge on the cation is balanced by charge of anion. That is already we have seen. This is the coordination compound. This is the cationic part. The cationic part charge is balanced by anionic part. So if complex is an cationic complex, then counter ion will be anionic. The same charge it is going to balance. If at all, if complex is an anionic complex, then the counter ion will be cationic part. So the charges will be balanced. So always if at all, if counter ions are there, then always we are going to write with the balancing charges only will be mentioning, and it will be always a neutral complex. As a neutral complex only will be mentioning that one. These are the rules for writing the formulas for the coordination compound. So we shall take few examples and see how to write the formulas. So names will be given to you. You need to write the formula for the complex. So we shall take the first example. First example. Example, sodium tetrachloridopalladate 2. So here two parts we have. So this is one part. We have a space here, and next this is another part. So here only sodium is there. Here we have tetrachloridopalladate 2. That is nothing but this is our central metal and this is our ligand. That is, so we can write it as coordination entity. This is our coordination entity or coordination part, and this is our counter ion. This is our counter ion. So sodium, it is given sodium is positively charged. So that is nothing but that is the cationic part. So in our formula, sodium comes first. We know that cationic part should be written first and then it is followed by the anion. So sodium is the counter ion. So how we can make out is we have two separate names here. So sodium, after that we have space, then it is followed by one name. So sodium is the counter ion, and counter ions, and sodium is positively charged, so it is an cation that has been written first, then it is being followed by the coordination entity. So we know that always coordination entity has to be written in the square bracket. So tetrachloridopalladate, palladate, that is nothing but palladium. Why that name had, why it is not given as palladium, why it is palladate it is given, that we are going to study in our next section, that is nomenclature. Now you just remember it is palladate, that is nothing but palladium. Palladium. So ligand is tetrachlorido. Chlorido is nothing but chloride. Tetra indicates 4. 4 chlorine, 4 chloride ions have been taken. Next, how many sodium atoms we have to write? They didn't mention about the sodium here. How many sodium atoms are there? They didn't mention. So the sodium atom, the number of sodium atom is based upon the charge on the complex, because counter ion is used to nullify the charge on the complex. So the number of sodium atoms, it won't be mentioned in the name. So we need to calculate the charge on the complex, so that the charge on the complex will indicate the number of counter ions. So here you can see within a bracket in Roman numbers 2 is mentioned. So if at all in a name after the central metal atom, so if it is mentioned in Roman numbers in the bracket, that indicates the oxidation state of that metal. So palladium is in +2 state. Palladium is present in +2 state. By using this one, we are going to calculate the charge on the complex, and the charge on the complex indicates the number of sodium atom. So we don't know now charge on the complex. We'll take that one as X. Same, if at all if it is X, Then sodium, we know the sodium always it belongs to group 1 and always it will be +1 charge only. That means that if it is -2, then sodium becomes 2 here. That is, whatever the charge on the complex it is there, the same number of sodium atoms we want. So we'll calculate first X. So leave about the sodium atom there. So leave about sodium atom, because if you write the sodium atom, you don't get the charge here. So sodium, you just leave it. We'll consider only this part. We'll consider only this part to calculate X. So palladium, what is the oxidation state on palladium? Oxidation state on palladium is +2. From the name it is given. So it is 2 plus 4 chlorido, that is nothing but 4Cl minus, and it is -1. It is -1 is equals to charge on the complex, that is X. Is equals to charge on the complex, that is X. So we can find out X is equals to how much here? So it is -4 plus 2, it becomes -2. So X is equals to -2. So we can write the complex as N of palladium Cl4. And what is the charge? -2. How to write the charge? Charge has to be written first the numerical value followed by the sign. It is -2, then it becomes whatever the X is there, that numerical value comes here. So now the coordination part is -2 charge. It is sodium is +2 charge. +2 -2 gets cancels. Then the complex is a neutral complex. I hope it is clear. So Na2 PdCl4 2-. So that is the complex.